Next, we are going to see the distance vector routing. So, in distance vector routing, the least cost route between any two nodes is a route with the minimum distance. So, what is distance vector routing? So, in distance vector routing, the least cost route between you are having two nodes, and the least cost route between two nodes is a route with the minimum distance. So, in this protocol, each node maintains a table of minimum distance to every node. Okay, so each node will be having a table, and in that table it will be having the distance, minimum distance to every other node. The table at each node also guides a packet to the desired node by showing the next hop in the route. So type of routing what you are using here is next hop routing. It will indicate, it will guide the packet to the next hop. So here, the first step what you're doing is initialization. So each node knows how to reach any other node and the cost. So in the distance vector routing, each node will be knowing how to reach any other node and the cost that is needed to reach the next node. Cost here is nothing but the distance. At the beginning, it is not the case. So each node know only the distance between itself and its immediate neighbors. That is, those are directly connected to it. So the initialization process is nothing but, so in the initially, each node will be knowing only the distance between its immediate neighbors. So each node will be knowing only the distance of the immediate neighbors. That is the neighbors, those are directly connected to it. So first, each node can send a message to the immediate neighbors and find the distance between itself and these neighbors. How it is doing this means, it will send one information to its neighbor, and it will ask the neighbor in how much distance you are. So distance for any entry that is not a neighbor is marked as infinite. So if there is some station and that station is not a neighbor of this particular node, then what it will do means it will put an infinity in the table. So that meaning of that is that particular node or particular station is in an unreachable distance. So second one is sharing. The whole idea of distance vector routing is that sharing of information between the neighbors. The immediate neighbors can improve their routing table if they help each other. So if one node, if it is sharing its information to its neighbor, then that neighbor will also get some information about some other nodes. So the sharing of information is the next important thing. The third one is update. When a node receives a 2-column table from its neighbor, it needs to update its routing table. Initially, the node will be having one table. That table will be having the information regarding only the nodes which is directly connected to it, or immediate neighbor information will be there. Now, if that neighbor is sending its routing table to the neighboring node, the neighboring node has to update its routing table. So this updating, there are 3 steps. First step is the receiver node needs to add the cost between itself and the sending node to each value in the second column. So in the second column of your routing table, what the node has to do means the sender node is sending its routing table to the receiving node. So now the receiving node has to update. So what it will do means it will add its cost. It will add the cost between itself and the sending node to the value in the second column. Then the receiving node needs to add the name of the sending node to each row as a third column. In the third column, the receiving node has to add the name of the sending node. If the receiving node uses the information from the row, if the receiving node is using the information that is sent from the sending node, then it has to mention the name of the node and the third column. The sending node is the next node in the root. The third step is the receiving node needs to compare each row of its old table with the corresponding row of the modified version of the received table. So next third step is what it has to do means it has to compare its old table and the new table. So two nodes are there. The one node is a sending node and another one is a receiving node. The sending node is sending its routing table to the receiving node. After receiving the routing table from the sender node, what the receiver node is doing is it is going to update its routing table. So for updating, it has to do three things. First, what it has to do means it has to add the cost between itself and the sender node to the second column. Second one, if the receiving node is using the information what provided by the sender node, then it has to use the name of the sender node in the third column of the routing table. The third step is what it has to do means it has to compare, the receiver node has to compare its own routing table, what it is previously having with the new routing table. So these are the three steps what it has to do for updating. So after doing that, if the next node entry is different, it is comparing. Third step is it is comparing. After comparing, if the next node entry is different, the receiving node has to choose the smallest cost. Okay. So it is comparing its old table with the new table. Now it is checking the cost. If the cost is low, then it has to take that. If both are same, it has to keep the old one. Okay. Now, next, if the next node entry is the same, if the next node entry is the same, the receiving node chooses a new row. Now, there are two types of updates are there. One is a periodic update, another one is a triggered update. Periodic update means a node sends its routing table normally every 30 seconds. For a periodic update. So every node will send its routing table to the neighboring node for every 30 seconds. So next one is so the period. So usual normal time is 30 seconds. This 30 seconds can vary depending upon the protocol. So triggered update means a node sends its two-column routing table to its neighbor anytime there is a change in the routing table. If there is any change in the routing table, it will immediately send the routing table change. If there is change in the routing table, it will immediately send. That is called triggered update. So the change can result from the following. So in a network, what are the factors that will cause the change? First one is a node receives a table from a neighbor, resulting in change in its own table after updating. So there's a first chance. First chance is a node is there. That node is receiving a table from its neighbor. So this node is updating its routing table. So after updating, it will send its routing table to its neighbor. So that is the first case. Second case is there may be any failure in the neighboring link. So there may be any problem in the network link. So that problem will also cause the change in the routing table. So whenever there is a there is a change in the routing table, immediately it will be updated. Triggered updation will be occurring. So first, this is a diagram which will be clearly showing what is happening in the distance vector routing. So here you are having A, B, C, D, E. 5 nodes it is having. So this is a routing table of A, this is a routing table of B, this is a routing table of C, and this is a routing table of E. Initially, all these routing table is having only the information regarding its immediate neighbors. First, we will take the node A. This is a routing table of node A. From A to A, the distance is 0. So A to B, the distance is 5. A to C, the distance is 2. A to D, the distance is 3. And E is not the immediate neighbor of A. So in the place of E, it is putting infinity. Now we are coming to D. So D to A 0. Sorry, D to first one A to D is 3. So D is not directly connected to B, so infinity. D is not directly connected to C, so infinity. So D to D is 0. D is not directly connected to E, so infinity. So the first initialization stage or initialization phase, the particular node will be having the information regarding its immediate neighbors only. Okay, it will be having information regarding the immediate neighbors only. So next one, updating. So this is a routing table. What it is getting from C. Okay, so this is a two column routing table. What A is receiving from C. Okay, A is receiving from C. So initially, what is a routing table? 0, 5. B for B, C, D, its value is 5, 2, 3. Okay, so 5, 2, 3 is the initial value. 5, 2, 3. 5, 2, 3 is the initial value of this is the initial old table. 5, 2, 3 is the initial value of what A's old table. Now it is receiving a table from C. It is receiving a table from C. For that, its cost is to reach A, its cost is 2, and to B, its reaching cost is 4, and for C, it is 0, for D, it is infinity, and E, it is 4. Now, A is modifying its table. A is modifying its table. Now, A to C. So, A to C, what is the distance? 2. So, that 2 is added here. So, 2 plus 2, 4. Okay, then 4 plus 2, 6. So, 0 plus 2, 2. 2 plus infinity is infinity. So, we are putting it as infinity. Again, 4 plus 2 is 6. So, what the first step is, it is adding to its original routing to the routing table. What it has received from C, it is adding the distance between A and C. Actually, it is receiving the routing table from C. So A to C distance is 2. So to all these values, 2 is added. And the third column we are putting as C. The meaning is the data is received from C. Now what we are doing is we are comparing these two. We are comparing these two. We are comparing. So here the shortest value is 0. So we are taking the 0. Next to the smallest value is 5. So we are taking 5. Next to both the value are same. So we have to take the same. Next to the smallest value is 3. We are taking the 3. Next to the smallest value is 6. So we are taking 6. So since we are using this value, this is a updated table after getting information or after getting the table from C. So since you are using this, we have to put the value C here. So this is a process of what? Distance vector routing. So first, initially, the first step, each node know only its what? Only its immediate neighbors. So if a particular node is not reachable, if a particular node is not an immediate neighbor, in the place infinity is put. So in the second thing, yeah, if a routing table is obtained from its neighbor, then first the distance between that neighbor and that particular node. Here A is receiving the routing table from C. So, but the distance between A and C is 2. So 2 is added to all these values. So you are getting 2 plus 2, 4, 4 plus 2, 6, 0 plus 2, 2, infinity plus 2 is infinity, 4 plus 2, 6. Now you are comparing this new table and old table. So if you are having the least value, then you have to take the least value. Okay, so 4, 0, 0. Since it is in the old, this value 0 is in the old table, no need to put the value of C. Here 6, 5. 5 is the smallest value. You are taking 5. 2, 2, same value. Here infinity 3. 3 is a small value. You are taking 3. 6 infinity. 6 is the smallest value. Since you are using this value, you are putting C. So this is the distance vector routing. The disadvantage of distance vector routing is 2 node instability and 3 node instability. The 2 node instability and 3 node instability are the disadvantage of distance vector routing.